So this is Objective 21. We are going to solve one-step equations today. We have just explained that today's lesson is not about finding the answer. It's about the process and how to write it. Everybody understand? Okay, here we go. So first of all, let's talk about what makes an equation an equation. How do you go from just an expression and then change it into an equation? You add a equal sign, okay? An equation is a mathematical sentence that contains an equal sign, okay? If it's got an equal sign, then it's an equation. If it does not have an equal sign, then it's called an expression. Any questions so far? Yay, nay? Okay, let's look at example 1. I'm going to ask you a couple questions to make sure you know the purpose and why we're doing each step. So my first thought is this: how many sides are there to an equation? I hear a bunch. I hear 2. How many sides are there to an equation? I agree. There's 2. There's a left side and there's a right side. Where's the center? The equal sign. And so what I'm going to do when we solve our equations, how many of you, like when you've gotten into some bigger equations before and you get lost in the middle of them? And somewhere in the middle of your equation, you even lose your equal sign. You forget to bring it down, and like you don't even know where it goes, and you lose your 2 sides. Do you understand what I'm saying? Maybe this didn't happen to y'all, but it does happen a lot. So what we're going to do to keep our 2 sides separate, we're going to draw a line. Now, I do want you to know, normally when you draw a line through an equals marks, it means that it's not equal. But we're just drawing a line through our equal sign just so that we can keep straight our left side from our right side. Okay? And some of you may like to draw the line and keep the line. The line is more like one of those things that once you get used to it, you can take the line away, but a lot of people like to just keep the line. Okay, I have even been over into the geometry classes, and I've seen them have equations on the board with lines down the center. And I'm like, oh, okay, they're still keeping the lines, and that's okay. You got your left side and you got your right side. Now I want you to think of it like a balance. Everybody played with the balance in science class? Yeah? What we do to one side, we must do to the other. So if I have a balance and I put 3 grams on this side, in order to keep it equal, I've got to put 3 grams on this side. What if I take away 2 grams from this side? Then to keep it balanced, I got to take away 2 grams from this side. What you do to one side, we do the other. We understand that, correct? Okay. What's the goal of your equation? To find out what C is? I agree with that. I like to say to get the variable by itself, or to isolate the variable. You with me? We don't want to know what C minus 22 is. I want to know what C by itself is equal to. What is C equal to? So, here's my thought. This is a typical one that you might have seen in elementary school, the way it is written. Okay, in a minute, I'm going to kind of change things up a little bit, okay, and progress you a little bit. So, C minus 22. What would I do to both sides? What's with the C, by the way? What do we got to get rid of? In order to get C by itself, I need to take the negative 22. Everybody agree it's a negative 22 now? Okay, and we need to get rid of it. How do you get rid of subtracting 22? In elementary school, you said adding. I'm going to change that. It's not, and it was last year. When you subtracted, you added. When you added, you subtracted. Follow along? But now, I need you to understand that it's the opposite of the sign of the number. What would cancel with a negative 22? A positive 22. Okay, and everybody says it's the same thing. But in a minute, it'll make sense when I start moving things around. Everybody understand that? So, here's how we write it. This is what I need you to learn. You are going, instead of putting it underneath, add 22, add 22, you are going to rewrite this. You're going to scoot it over. That's going to make room for what I'm going to do. What you do to each side must go on the end of it. Equals 54. And so, everybody understand, I rewrite this, And on the end of it, I write plus 22. And then I rewrite the 54, and on the end of it, I write plus 22. What do I do to one side, I do to the other? So it's the same thing, except instead of writing it underneath, I write it sideways. Okay, it's the same thing. It's going to feel weird for a little while, but you'll get used to it. So tell me, what happens here? And we say they cancel. And I say, why? And everybody says, I don't know, they just do. They are opposites. What do they make? They make 0, and anything plus 0 is itself. Okay, you need to understand that. And then 54 plus 22 is 76. Okay, so C is equal to 76. Any questions on that? Everybody good so far? Okay. Here's where we start mixing things up and kind of rearranging the order. Okay. Here's my middle. Where's the middle? At the equal sign. You got your left side, you got the right side. My goal is to get G by itself. What's with the G? A positive 25. Now, this says I'm subtracting over here. How many think I need to add 25? How many think I need to subtract 25? Because what did I say? You know, in elementary school, it's if you were subtracting, you added. If you added, you subtracted. Well, this subtraction sign has nothing to do with the 25. The 25 is positive. What's going to cancel that 25? A negative 25. So it's changing it now. It's now you need to do the opposite of the number that's with it when you're adding and subtracting. Okay? So I'm going to rewrite the 113. Why do I scoot it over? So I have room to put what I'm doing to both sides. So I'm going to rewrite this, and on the end of it, I'm going to put what I'm doing. So I'm going to subtract 25 and subtract 25. Any questions on that? Can I say something really quickly? Some people earlier today were doing this. Subtract 25. Is that right? That doesn't say subtract 25. That says to subtract 113. And you will get the wrong thing. Okay? It is very, very important that you rewrite what you have first. You with me? Scoot it over. And on the end of it, that's key. Because if you don't put it on the end of it, so, I mean, most of the time it'll be okay, but if you put it in the beginning, but a lot of times if you don't put it on the end, it won't say what you want it to say, and then you'll get the answer wrong. Do you understand what I'm saying? Yay or nay? Yeah? Wiggle your nose for a yes. Don't you ever wish you could do that? Anyway, minus 25. I can't do that. Okay? So, 113 minus 25 is? Come on. 113 minus 25. 88. Okay. What happens over here? I got a positive 25 and I got a negative 25. The positive 25 and the negative 25 will what? Cancel. They cancel because they make 0. What am I left with? Negative G. So, am I done? Is G by itself? We've got to fix it. We only solve for positive variables. We do not solve for negative variables. Okay? So I'm not done. My variable's got to be positive. So I'm going to show you the technical way, and then I'm going to show you the easy way. You ready? Technically, what is here? A negative 1. And what's happening between them? They're being multiplied. In order to get rid of something, you do the opposite. So the opposite of multiplying by negative 1 is to divide by negative 1. And everybody says, Ms. Corns, I thought you had to change sign. We only change the sign when you're adding and subtracting, because an adding and subtracting, the opposite is changing the sign. The opposite of adding, a positive, is subtracting a negative. You with me? And so that is the opposite. But the opposite of multiplication is simply division. It says nothing about flipping signs. Do you understand? So if we're timesing by negative 1, to get rid of it, you will divide by negative 1. A negative divided by a negative is a positives. They do cancel and gives you a positive g, and this will give you negative 88. That's the technical way. So technically, you're dividing by negative 1. Anybody up for the easy way? What you do to one side, you do to the other. Everybody agree with that statement? You got your balance? Whatever I do to this side, I must do to this side in order for them to be equal. So if I change the sign on this side, then I change the sign on the other side. What you do to one side, you do to the other. Okay, that's the easy way. But technically, you're dividing by negative 1 on both sides. Everybody okay so far? Okay, why don't you try this one on your own? Try this one. All right, so goal is to get m by itself. What's with the m? A positive. So this plus sign, does it help me out at all? Not really, because that plus sign belongs to the m. That's a positive m, okay? But this plus sign, that's the sign that tells me what to do. The opposite of that. So I'm going to rewrite 63 plus m, and on the end of it, I'm going to put minus 63. I'm going to rewrite the 79, and on the end of it, I'm going to put minus 63. A positive 63 and a negative 63 will cancel. What am I left with? M, and 79 minus 63 is 16. And again, I know we all knew the answer was 16, right? Did you write it like that, is my question. Can you write it like that? That's the important part for today. Okay, what's different about this one? Something specific? What do you mean it's switched? Okay, something else. I agree, I've added a negative answer, but the key here is the fact that there are double negatives. What do we do with double negatives? We got to rewrite. So here's what I'm going to tell you. Right now, what if you started solving right now? What would people tend to do? Plus 16. You with me? Ain't going to get you the right answer. Okay? We know that before we begin, we have to rewrite this. Everybody sees a double negative. Okay? I'm going to bring down the negative 12. The two negatives go out the window, and in its place goes a positive. One positive. Okay? And you're going to bring down everything that you did not circle. So what did I not circle? The P and the 16. Now solve it. Okay? With what you have written. Now you solve it. Any questions about changing double negatives into a positive? What do most people call that from elementary school? What do we just do? Copy, change. Same thing. All right, so I'm going to rewrite the negative 12, and then what am I going to put? Minus 16. I'm going to rewrite the P plus 16, and on the end of it, I'm going to put minus 16. Okay, on either side. So, on this side, what happens? Negative 28. On this side, these cancel. Why do they cancel? Because they make 0, because they're opposites, and P plus 0 is just P. Okay? So the goal is to get R by itself. What's with the R? Now, am I going to add 3 to both sides? You got to look at what's happening. There should be two things. You got to say what's with the variable, negative 3, because that's what you got to get rid of, okay? And what's going on? They're being multiplied. And so the opposite we're going to divide by negative 3. Okay, and a negative divided by a negative is a positive. Somebody explain to me, why do these cancel? We know they cancel, but why do they cancel? Because they make, what do they make? They make 1. If I divide 3 by 3, I get 1. And 1 times R is just R. So you need to understand, when you're multiplying and dividing and they cancel, they make 1. Because 1 times anything is itself. When you're adding and subtracting and they cancel, they make 0. Because when you add 0, it's just itself. Okay? And so 39 divided by negative 3 is negative 13. Does everybody understand why you don't change the signs? Because the opposite of multiplication and division says nothing about changing signs. Opposite of multiplication is division, vice versa. Why do you change the signs with adding and subtracting? Because that's a part. Adding is a positive, subtracting is a negative. That is the opposite. Okay? All right. How many will fully admit you take a look at this question and you think, skip it, I don't want to do it, it's a fraction. I got a bunch, okay? How about I sell a pitch to you? You ready? What if I told you I know a very easy way that we could get rid of the fraction? Okay? I know even how many, I agree, you could take that to a decimal and work with it as a decimal, but how many still don't want to work with decimals? Like, you just don't like either one. Would you rather work, what if I told you I could take it away and make it a whole number? Would it be easier? Anybody buying into it? Am I a good seller? So in my next life, I'm going to be a salesman. Okay? Not really. So here's the thing. Here's what we say. Ooh, yuck, gross, disgusting, nasty. Any other not very nice word you can think about fractions, right? Let's get rid of it. Okay? Here's how you do it. Repeat after me. In order to get rid of a fraction, you multiply by the denominator. In order to get rid of a fraction, you multiply by the denominator. To get rid of a fraction, we're going to multiply by the denominator. To get rid of this fraction, we need to multiply by 4. Okay, and here's what I'm going to tell you. Some teachers, you know, there's different ways to do a problem. Some teachers make students add fractions, subtract fractions, common denominators, multiply by the reciprocal, keep it, change it, flip it, and do all of that stuff. What I do is I multiply by the denominator from the get-go. And what it will do is it'll just wipe out the fractions on the first step. And then after that, if you have no fractions, then it's easier. Okay? So do realize I could sit here and make you find common denominators and, you know, multiply by the reciprocal and do this and do that. And those are doable ways. There's nothing wrong with doing those ways. But I think this is easier. Okay? So we're going to times everything by what? Why? Because to get rid of a fraction, we need to multiply by the denominator, and our denominator is 4. Can somebody explain to me why multiplying by 4 is going to wipe that out? How did we multiply 4 times 3/4? Because it's 4 over 1 times 3 over 4. Anybody see it? What happens? It equals 3. Yeah. What happens when I cross reduce? What happens? This becomes a, and this becomes a 1. And when I multiply, I'm just left with, oh, snap. Can I say that? What did I just do? I made it a whole number. Better than making it a decimal. Better than dealing with fractions. We got rid of it. And because I multiply by 4 on this side, I need to multiply by 4 on this side, and I get 24. I will tell you, you and your calculator can do 4. Everybody do this for me. Put in your calculator. 4 parentheses times 3 divided by 4, close your parentheses. Don't worry about the q. We'll just bring the q down. Okay? But put 3/4 in parentheses. 4 times parentheses 3 divided by 4, close your parentheses. What do you get? 3. Your calculator will do it with you. But I do like for you to know that the denominators will cancel. Okay? And you just bring down your 3 and you just bring down your q. Now tell me, explain to me why this. Why didn't I times the 3 times both of them? How many things are in here? Really? How many terms?
1.
Why is it one term? Why am I only timesing it in one time? Because they're together. You with me? So once I times this in, once they cancel, I just drop the 3 and drop the q. Okay? They go poof. Now it's a lot easier. Everybody agree it's a lot easier. How do I solve it now? What's with the q? What's with the q? Timesing by 3. So to get rid of it, I will... Do I need to switch the sign? No. Because the opposite of multiplication is simply division. Does it say anything about switching signs? No. When do we switch signs? When you're adding and subtracting, because that is the opposite, right? Okay. So 3 divided by 3 does cancel because it makes 1, and 1 times q is just q, and so q is equal to 8. Okay. First block said, does that work every time? Yeah. To get rid of a fraction, you multiply by the denominator. What will happen? It'll cancel out. And you just bring down the numerator. No fraction. Okay? So let's look at another one. Ooh, yuck, gross, disgusting, nasty fractions. Oh my goodness. Fractions. Let's get rid of it. How do I get rid of it? Multiply by the denominator. The more times we keep telling ourselves this, the more times we will remember it, right? So what am I going to multiply by? 2. So I'm going to times by 2 on this side, and I'm going to times by 2 on this side. Tell me, what happens to the 2's? Really? I thought that makes like a 4. 2 times 2? Because why? This is in the numerator. This one's in the denominator. So I agree. They cross reduce and make 1s. So what am I left with? Negative 1w or negative w. So far, so good. Am I done? No, I only solve for positive variables. We don't like to be around things that are negative, right? We only solve for positive things. So, technically, what am I going to do? Technically, I'm going to divide by negative 1 on both sides. So, w would equal negative 16. The easy way is switch the sign, switch the sign. Okay, that's the easy way. Okay, any questions on that? How many like this whole multiplying by the denominator thing? Makes our problems a lot simpler. Okay, can somebody, being my awesome smart class that you are, can somebody tell me a way to do this all in? I did this in 2 steps. Could you tell me how I could do this just in 1 step and be done? What could I have done in the beginning, Tanner? What do you mean? Let me show you something. Can I show you a shortcut? Is that okay? Is it okay to do 1 at a time? Do the denominator, then take care of the negative. You could take care of the negative and the denominator all in 1 step, though. Watch this. Let me explain. This is negative 1 over 2w. What do we say about the negatives in our fractions? Where do they go? Where do I stick them? Remember in the beginning of the year, and y'all like, what do I do with the negative? And I told you that negative 1 over 2 is the same thing as negative 1 over 2, which is the same thing as 1 over negative 2. Remember I said the negative can go in the top or the bottom or the middle, but not both. Why couldn't I put it in the top and the bottom? Why couldn't I have a negative over a negative? Because then that would be a positive, okay? But it doesn't really matter. So what if I, like, right now, he's out in front. Agreed? What if I took him and put him in the denominator, and I times by negative 2? Negative 2. What, a negative times a negative? It's a positive, and the 2's cancel, and 8 times negative 2 is, how many like that? All in 1 step. And that's fine. How many like doing it better than the 2 steps? Multiply by the denominator first, then bring down the negative and take care of it. And that's fine. But I do want you to know, as far as these negatives go, it don't matter where it goes. You can put it in the numerator, you can put it in the denominator, just not both. It can go in the top or the bottom, but not both. That's my softball It can go on the top or the bottom, but not both. You with me? Yay? Nay? Sandy's like, please don't ever do that again. Did y'all do that? Do they do that though, or is that just on like movies? You don't get out there and do this? I think you should make up one and do the truffle shuffle. Do y'all know what the truffle shuffle is? Anybody know where that's from? Goonies. You know what I'm talking about? Chubby. Okay. Anyway. All right, try this one on your own. I feel a little silly today. Try this one on your own. Everybody says, is there a fraction? Yes, there is. What fraction is there? Well, but what actual like fraction numbers? That's 1 over 7. Like another way to write this, just to letting you know that it's the same thing, is to say 1 over 7. This is the same. Everybody agree there's a 1 up top? Same thing. Okay, so regardless of how you see it. So, ooh, yuck, gross, disgusting, nasty fractions. Get rid of it. All right. So this should make sense to us. You saw ones like these. I mean, now we're saying it's a fraction, get rid of it, multiply by the denominator. Or you can say, what's with the m? I'm dividing by 7, so to get rid of dividing by 7, we're going to multiply by 7. And do notice, how do we symbolize? Because today's about how to write it. Okay? When we're adding and subtracting, I showed you how to write it out to the side. Yay? When we're multiplying, how do we symbolize it? With parentheses. When we're dividing, we make fractions, right? Okay? So, that makes 49. 7 times 7? Because this 7 is up top. Okay? They make 1, and you get 21. Any questions? All right, try that one. Only one more after this, just in case you're counting. So, do we see a fraction? What fraction is there? Negative 1 over 9. Everybody agree? Negative 1 over 9. So, in order to get rid of the fraction, there's 2 ways to do it. I'm going to do it in 2 steps. So what would I do? I'm going to times both sides by 9. Okay? So you could times both by 9. I just caution you, what are you left with? You know what a lot of people do? What do they bring down? Just m. Okay, make sure everybody realizes we're left with a negative m equals 90. And so the easy way to get rid of this is change the sign on this side, change the sign on that side. That's the easy way. Okay, technically you're dividing by negative 1. How many multiplied by negative 9? So I had several that did that, and that's fine. Does that make sense? Is it okay? Is this the same thing as the beginning? Yeah. Remember I said it doesn't matter if the negative goes in the top or the bottom. You could put that down there with the negative 9 and times by negative 9 on both sides. So that'd be fine. You can do it all at once. Okay? All right, last one. What do we think about this one? Somebody earlier said, well, we know to get rid of a fraction, we multiply by the denominator. But I got 2 different denominators. Somebody said, could you times by 5 on one side and by 4 on the other? Why not? You got to do the same. In order for it to stay equal, you got to do the same thing to both sides. Okay, so that doesn't work. Anybody have any other thoughts? I hear times them kind of by both. Even better, say it louder. I hear 20, which is what that would do. Okay, by 5 and by 4. Because, why 20? Because it's a common denominator. So when you have different denominators, you times by a common denominator. Now I'm going to tell you, could you put this in your calculator and get the answer? Like, can you put in 20 times 2 divided by 5? Check it and see. What do you get? Now, here's the thing. 20 over 1 times 2 over 5, it does not completely cancel. But what will it do? It will reduce it. This becomes a 4. This becomes a 1. It will reduce it, and then when you multiply across, and everybody says, but that didn't cancel it, Miss Corns. Well, what was my goal? To get to a whole number. And it does do that. Okay? Same thing here. If you're going to put this in your calculator, don't put the x with it. Just do 20 times parentheses 3 divided by 4. Okay? If you do it by hand, 3 over 4 times 20 over 1, the 20 becomes a 5, the 4 becomes a, so when I times across, what will it give me? 15x. You just drop the x down. Okay? Now here's the question. Do I divide by 8 or divide by 15? Okay? Some people, because they want to divide by the smaller number, and they don't know which one to divide by. Here's the thing. You got to go back to your original statement. What's the goal? To get x by itself. What's with the x? What do I got to get? What do I need to be focused on? Getting rid of the 15. And if I'm timesing by 15 to get rid of it, I'm going to divide by 15 on both sides. It's always about the variable. What's with the variable and getting the variable by itself. I don't really look to the other side. I kind of like ignore this side and I look at this side. How do I get x by itself? Those will cancel. Why do they cancel? Because they don't make 0, they make 1, and 1 times x is x. Silly. What's my answer? I hear 8 over 15. I hear 0.53 repeating. So which one's better? 0.53 repeating or 8 over 15? 99. I know we say, ooh, yuck, gross, disgusting, nasty fractions. I understand that. But at the end of the day, how do I want your answers? In fraction form. So you can divide them, get a decimal, go math, enter, and give me the most simplified version of it. Does that make sense? Everybody, y'all do know math, enter? I've showed y'all that before. So 8 over 15 is what I want. The only time I want a decimal is when? The only time I want a decimal. When I say so. When the problem has a decimal. If the problem has a decimal, then you want to work it as a decimal. But all other times I want fractions. Okay? Does everybody understand that? So when you divide it and it doesn't come out evenly, just leave it like simplified fraction. Okay? All right. So we're going to stop there. I'm going to let you